Hello, everyone. Thank you for coming. I'm just in the process of admitting everybody. We have quite a few people registered for this today, given the topic, the ScyLight program and the HydRON project. I just wanted to let you know that we are recording this and we will be posting this later to the SatCan and the Optical SatCom Consortium website. So we will get started. And I will continue to admit people as they come in. So hello and welcome to our meeting with the European Space Agency. We're very excited to hear about the ScyLight program and the HydRON project, which is a similar technology that the Optical SatCom Consortium is also working on. So I am Michelle Mendez. I'm the president of Satellite Canada Innovation Network. We are a not-for-profit organization that is dedicated to supporting the Canadian space sector, both at home and abroad. SatCan is also the secretariat to the Optical SatCom Consortium, and we will be hearing more about the consortium later. So before we get started, I just wanted to get some housekeeping items out of the way. This is the agenda for today. I think everyone saw that on the registration. So we're going to try and keep to time, but if we go over, we will be respectful of everybody's time. But if there are any questions that aren't answered here today, you can send them to us and we will forward them to the appropriate person. So just some housekeeping. We know that you've been doing this for 18 months, but we would just like to ask everyone, if you are not speaking, to please mute your microphone. We would also ask that you would please deactivate your video just for bandwidth issues. We have encountered issues in the past, and which is why it's a great thing that we're all working on these things so that they don't have to be an issue in the future. So if you do have any questions, we will be answering at the end of all the presentations, near the end of the meeting. And again, if we run out of time, please send us your questions and we will forward them to the appropriate organization or individual. So I just like to make some introductions. And clearly my mouse doesn't want to play today. So the speakers that we have today are from the European Space Agency. Dr. Harold Hauschild is the manager of ARTAS 4.0 strategic program line on optical communications in ScyLight. And I'll let them each introduce themselves. I'll just go through their names here. So there's Mrs. Monica Politano. She's a HydRON systems engineer at the European Space Agency. And Dr. Chris Vasco, the telecommunications system engineer at the European Space Agency. And locally within Canada, we have Dr. Sylvain Raymond. He's the Deputy Director of the High Throughput and Secure Network Research Program at the National Research Council. So we will be using a lot of acronyms today. So if you have any questions, please raise your hand or put them in the chat. And we'd be happy to provide the acronym in the chat. So perhaps we'll start with Chris to introduce himself. And I'm not sure if Harold was able to dial in today. So I'll let Chris, I'll just turn it over to Chris.
Thank you very much. Thank you, Michelle, for the introduction and welcome everybody. My name is Chris Vasco. Indeed, my boss, Harald Hauschild, who is my and Monica's manager, unfortunately seems to be stuck in a flight. At the moment, he is on mission here in Europe. So also on behalf of him, thank you very much for joining us today. Very briefly, I'm a telecommunication systems engineer here at ESA. I am also working on institutional relations as well as stakeholder relations, supporting Harald Hauschild in the strategic program line Optical Communications ScyLight. I'm today joined by Monica. Monica, would you like to introduce yourself?
Of course. Good afternoon. My name is Monica Politano. I have a master's degree in aerospace engineering and specific technical, let's say, experience on some satellite disciplines, and then on the old satellite platform development and technology management. I leave you the floor, Chris. And I'm supporting HydRON for specifically the platform aspect, and then anything that is needed in this preparatory phase.
Thank you. I think that's it from our side, Michelle.
Okay, thank you very much. And I'll just turn it over to Sylvain to introduce himself.
Yes, good morning, everybody. My name is Sylvain Raymond. I'm from the National Research Council of Canada. It's very nice to see you all this morning. My background is in physics. I'm a photonics person developing materials and components to do photonics systems. And I've been at NRC for over 21 years. The first 10 years, I was a researcher. The past 10 years, I've been doing mostly project and program management, or involved at least in project and program management at NRC. And more recently, I've been involved in the management of the high throughput and secure networks challenge research program. If you just type HTSN, which is the acronym in Google, you will find our website and you can get more information. Thank you very much. I'll be pleased to meet you if I get the chance to talk to you later.
Great, thank you, Sylvain. So now I'm going to turn it back over to Chris, and they were going to be providing us a presentation on the secure and laser communications technology, ScyLight, and the high throughput optical network, HydRON. And I will turn it over to you, Chris.
Thank you. Let me bring up my presentation.
It's great to see so many people here today from all walks of life, and how interested Canada is in this technology. So thank you so much, Chris, for being here.
Thank you for having us. Can you see the presentation?
Yes, we can.
Excellent, thank you. Good, so we have half an hour or a bit more than that to try to walk you quickly through our activities at ESA concerning optical and quantum communication. This is, of course, not enough, and it might feel rushed at times, but that's why we have set aside some time for questions later. And I would immediately like to start off that we are very happy to be able to present to you today, simply because the activities we are rolling out under ScyLight have been around for quite some time, and we do think that there is a great potential in Canada for Canadian participation to our activities, and we actually need all of you on board with these activities, since as any agency's main goal is to develop technologies that are useful for industry, and we cannot do this without you. So we are very happy to be able to talk to you today. And I do believe that I'm preaching to the choir, but in case you're new to the topic, why would we even consider optical communications? And you can oversimplify it to the performance and the networking capabilities of optical communications that are, quite frankly, astonishing at this point. We are talking about roughly 3 orders of magnitude more bandwidth than we can currently achieve. This, in combination with lower weight, mass, and power requirements, that gives you potential savings for the satellite real estate and makes your system cheaper. And consequently, you might even be able to decrease very complex systems of high throughput satellites, paired with you're using optical, and thus you're quite free of frequency and bandwidth restrictions. These are the reasons why we are engaging in optical communication. And while all of this sounds fantastic, we also have to be very aware of the fact that this is new, and this is relatively new and relatively disruptive to the market at the moment. Since if you compare this to traditional radio frequency systems that have more than 100 years of heritage right now, we are not yet there to actually offer off-the-shelf solutions. So there is still some work to be done. but the technology is maturing quite quickly, and quite a few key technologies are getting ready as we speak. And now comes, in essence, the push to assess what we have, where are the gaps, and what we need to do, and the preparation, in essence, to implement a fully operational optical demonstration system. That's our motivation to go optical. As the European Space Agency, we have established a strategic program line in our telecommunications and integrated applications department. This strategic program line is a tool for us, or a way for us to engage with industry, but also to expand our activities more in, let's say, a less traditional way than our department usually works. TIA in ESA is known to be very good in industrial collaboration and public-private partnerships. So what we've been doing so far is either to initiate or to work with industry to initiate activities. But within ScyLight, we are also able to push our own demo missions to highlight technology that we, as European Space Agency, find interesting and exciting. And we're doing this with the vision to establish industrial excellence and market lead in optical communication technology in the coming 5 years. Well, I have to correct myself now, it's in the coming 4 years. But as you can see by the word cloud, there's been a lot of activities that we are considering under ScyLight. And one of the reasons why we are doing events such as this one is to be sure that that word cloud on the right-hand side also encompasses your interests and your technologies that you would like to have developed. That being said, we can break our activities very roughly down into system and economics, photonics or optical payloads, and quantum communication systems. And very obviously, in terms of technology, we are talking about the new generation of laser communication terminals that would be flying on satellites. Here we are referring to quite a big array of terminals, everything from airborne small terminals that you could embark on an aircraft or a drone to constellation laser terminals, as well as small-sized and new terminals for geostationary orbit. But of course, having something in orbit that flies optical technology is not enough. So we are also considering feeder uplinks and downlinks, the adaptive optics that we would potentially need on the ground station to communicate. We are obviously very interested in intersatellite communication and optical payloads that support optical communication. And then down the road, quite clearly, we would like to be sure that we are optimizing the production of such systems, while we are keeping the door open for new emerging systems that are going to be exploiting the quantum nature of light. So anything that has to do with quantum communication is something that we are interested in. In terms of applications and services, quite concretely, we have a number of activities that we are sharing across the agency and also in our department that have to do with cryptography and cybersecurity, namely quantum key distribution technologies. Here we are very closely collaborating with the European Union. But we also have our flagship project HydRON, which is our high throughput optical network that my colleague is going to talk about, as well as a first quantum key distribution system called Saga. From a system perspective, quite obviously, we are interested in crossing the T's and dotting the I's when it comes to atmospheric physics, to be sure that future systems, whatever shape and form they will be taken, can deal with the challenges of actually trying to pass a number of photons from 40,000 kilometers away to our users to be used in whatever application they want them to use for. For that, obviously, we are not only relying on our flagship missions that I just mentioned, but also on in-house demonstration missions that we're hoping to develop under ScyLight. And without going into too much detail, you'll be able to read this up, because we will be sharing the slides with you after this. We have a first roadmap for the coming 5 to 6 years, where are a number of topics I already elaborated that we are looking into concretely. We can break them into two branches. One of them is more general optical communications. Here you will find our flagship HydRON, the terminals that I'm talking about, but also the ground station systems that we will be needing and the technologies that we will have them to run. But also more general topics ranging from the adaptive optics I mentioned to the airborne terminals. And on the other side, you have the quantum stream, where we are trying to support quantum memory research at the current stage, going all the way to the first demonstrator missions of quantum key distribution and specialized technologies for quantum communication. But that being said, I will now hand over to Monica to tell you a bit about our flagship HydRON.
Thanks, Chris. So you will be moving on for me the slides.
Yes.
Again, good afternoon or good morning for you. I will walk you through the HydRON project, explaining what is the concept of HydRON. It's already been somehow introduced by Chris, and also what is the project, so what we are going to develop in the coming years and hopefully fly. Next slide, please, Chris. The vocation and the mandate, let's say, the mission statement of HydRON is to offer basically a seamless integration of networks, meaning what at the moment our current telecommunication satellites or in general capabilities are not offering, are not focusing on, or are not capable to offer. We are not going to bridge the last mile as current telecommunication satellites are doing. We will try to be connecting existing and future networks, being based on space or being based on ground, in a seamless way, meaning that this will be hopefully transparent to users. And we are going to try to do this in a way that will allow to patching on demand, to be configurable by the network, and also to offer some type of routing capabilities. This is quite ambitious, and we will try to do this, so to offer this sort of high data rate data transport service, because this is what it is, based on full optical technologies. There are at the moment constellations that are partially already offering optical to exploit, let's say, the optical technology benefits, mainly in space, but most of the time they are going then down to ground, so repatriating data via RF, because there are a lot of challenges in going fully optic. But we have spent the last 2-3 years almost in analyzing the feasibility of what we call the vision, the full concept, what we have been calling the full mission. That is not what we're going to fly, but is sort of paving the way to the current project. Next slide, please, Chris, because this picture I think is quite is much clearer than many words. HydRON is sort of offering an optical overlay that would potentially integrate with the existing networks and offer to transport at a much higher data rates the data, any type of data, telemetries, etc., that other users or network of users will be producing, basically accumulating, and also will be offering capability to repatriate the data to ground, thanks to this ambition also to be compatible with ground-based networks. Next one. Thanks. Now, what I mentioned before, on one end, we have defined the mission, which is, if you want, the complete scenarios that is aiming at showing or at describing, let's say, for potentially future customers and operators, what could be the possibilities that are seen as let's say, upcoming and materializing for the future market. ESA is not going so far. ESA is analyzing what could be the future scenario, is going to derive a minimum, let's say, set of features and the minimum architecture that would be needed in order to demonstrate the crucial capabilities or the crucial technologies that might be enabling for the full scenario, and then is offering this to future customers, basically to operators. To do this, what we're going to do, what we are doing already actually, is to identify on one end the minimum set of technologies that are needed to be demonstrated in order to demonstrate that this dream is feasible. And this is not a dream, and it's something that might materialize in a few years. And then in parallel, we are also trying to understand with the architecture, the minimum architecture that we are going to set up and fly, if we can already offer a service. And this is what in the last line here, the text you see has highlighted as minimum viable product, because we are sure already that the technology requirements that ambitiously we're going to demonstrate are already quite enough to sort of offer a minimum service. And I'm going to describe later which, let's say, in which directions we are now going in order to identify the services that we can offer or the type of customers we will try to serve. Next one, please, Chris. Now, the project. The project is what, from a programmatic point of view, what we are developing now. We have just issued an ITT, so an invitation to tender, for the phase A-B1 of what we call the HydRON project that is focusing on the demonstration system. What you see here identified with the acronym HydRON DS. What I described before, that was, let's say, the general visionary concept, is what we used to identify as HydRON mission. And now, as a subset of the architecture, the concept, and the requirements, we are going to actually develop and fly what we call the HydRON DS, the demonstration system. This HydRON DS might include 1, 2, 3 satellite. It depends. Might be geo-based, or might include also some LEO nodes. We have quite sound ideas, but the industrial study that we are going to start by the end of this year will confirm in terms of potentialities for a future exploitation in terms of business case, which is the minimum configuration that is affordable in order to demonstrate in a convincing way for the operator that this concept can work. But the main features are this bullet that you see here on the bottom right side, that we have to arrive, let's say, at a good level of, at a good data rate, maybe not immediately to terabit. Probably we're going to focus on 100 gigabits per second, but let's say something meaningful. We are going to demonstrate some crucial capabilities like optical switching or electrical switching. We are still in the middle of trade-off to understand which is the best strategy. We are going to study how to collect and possibly repatriate and distribute customer data, even if our goal is not to arrive, as I say, to go the last mile to arrive to the individual customer, but just to deliver these to the operators. And finally, to do this in a way that is completely transparent to the users, so that the management of the network and the routing capability will be so smart that basically the data will find the smartest and better and best path, let's say, to go from A to B. Next one, thanks. Now, the system, the bottom left picture is explaining exactly what I said before, the logic from the full scenario down to the minimum portion of this scenario, that is what we are going to fly. Just to give you some examples, but as I say, this is not yet cast in stone, a reasonable subset of or let's say portion of the full system could be maybe 2 geo nodes, may be complemented by a LEO node, depending on which type of customer and application we might give priority to. If we need to decrease, let's say, the latency requirement, then we might need a LEO node in order to arrive to LEO users. If not, then we might concentrate on the GEO nodes, for example, in favor of coverage. So it really depends. But I dare to say that we are relatively advanced there, and the business case has been already analyzed in general terms during the full mission phase 0A, and now we are going down to something I would say quite factual. Next one, please, Chris. Oh, to do this, we have been analyzing in the last, I would say, 2-3 years, the typical user categories, and we have basically defined in our role as ESA of system architect a complete set of requirements, and this set of requirements, what we call the mission requirement, has been and is being basically iteratively reviewed with the support of the HUG, the HydRON user group. And we have identified 4 categories of users that you see here. This slide is already quite known for the last 2 years: terrestrial network operators, private network users, satellite and airborne users, and telecom operator. And we're now confident this, let's say, macro categories more or less cover all applications. And the idea is that we will work on the refinement of this requirement in the coming, even if we have a good baseline now, in the coming months. And this will be finally injected in a sort of more frozen way in the industrial studies by the end of this year. Next one, please, Chris, and I will, okay. Now, we are, as I said, from a programmatic point of view, just starting, well, from a practical point of view, will be started, kicked off by the end of the year, beginning of next year, the phase A-B1 of the demonstrator. So we'll be going through a definition phase and then a development phase, which will basically be what we call phase B2CD-A1, and then the demonstration phase, where we will operate with the goal of demonstrating the basic capability in an end-to-end way, the system. The current phase, maybe the next slide, please, is clearer in that respect. No, let me jump, sorry. If you go ahead. Go ahead. Ahead one. Okay, here, because I prefer to set the complete scenario. As I said, we have opened this ITT. In parallel, we are doing 2 things. We are running critical technologies development, and this the previous 2 slides. I will go back to those, but it's just details. Because we have identified a set of crucial technologies that are considered enabling for whatever will be the specific tailoring of the application that we will be implementing after, let's say, the next 3 to 5 years. And this is being done basically. It already started. It's a process that started already last year, and this is continuing also this year. So Canadian industries are invited to regularly check the invitation to tender or to ask us about that, because these are already quite good opportunities. And then in parallel, the system studies, so where also Canadian industries are invited to team up with the primes who will be winning this, well, 1 or 2 studies. Often the practice of ESA is to have, whenever is needed, parallel studies at this stage. To team up with the future prime. The study, the phase A-B1 will last more or less a year and a half, but because next year we have the council at ministerial level, we have the tough goal to have already some input by basically mid next year. So this means that in terms of cost and affordability to size the mission, the demonstration mission, all our work will have to be already focusing on let's say, a preliminary result in 6 months. And there will be let's say, the proposal for the ministerial in terms of capability requirements and budget will be basically shaped in view of the end of the year ministerial. And in parallel, by the time we will be preparing or starting the preparation of the real development phase, so the phase T2CD. Now, Chris, if you go back 2 slides to the critical technologies, I will just show some examples, but we will be distributing this presentation. So who is interested can go through the individual activities or even ask us more details. But just to give you an idea of the priorities, for example, the simulator was considered to be one of the very first priorities, and this is already at evaluation level, because thanks to the simulator, we will then, and the industrial team will be advancing also the analysis of the scenarios and the identification of the promising applications. And then you see here other examples. The wavelength division multiplexing capability, the optical switch matrices, and etc. I think we can then skip these details and we go to the next one and next one. Okay, now bottom line, just the conclusion here. HydRON has been, let me say, preliminarily analyzed and assessed as a concept in the last years. It's very challenging, it's very promising, and we have seen that it can really become real, and that there is quite some interest. Now, there is interest also for the application, both in the open market, let's say, so beyond the institutional application, but also within ESA. And we are in contact with our other directorates, like Earth observation and navigations, where we might find some type of initial customer. Nothing is decided yet, and we're still analyzing the mutual requirements, but this is showing to be quite attractive. What will be crucial for the future, I have the feeling, is not that much the technical feasibility, because I think that this will be probably demonstrated quickly, is the demonstration of the business case, so that we are capable to do better than let's say, the best, for example, KA-based RF system, but this is probably already clear from a technical point of view, and that we can be cheap enough and reliable enough to be competing with them. I think it's a big challenge and it's a big opportunity for everybody. We expect a lot and from Canadian industries, and you're invited to look into what we're doing and also feed us offline, as you like, questions, because I think it's a big opportunity also for you. And with this, I think I'm done. I leave the floor to Chris for Saga and any type of general question.
Thank you, Monica. Looking at the time, I think I have some 5 to 6 minutes left. That should be plenty of time. Before we wrap this up, I would like to touch on our quantum communication activity, Saga. I would like to give you a brief overview of what Saga is and what we are working on currently. I think this is, for all of you who are in QKD, this is a known fact. Research and development is very hot. It is a hot topic at the moment. We are in Europe alone, and of course, this is not necessarily very relevant now for North America. We have alone here 10 national QKD activities at least. We have several test beds that are showcasing and starting to connect cities and regions with QKD test beds. At ESA ourselves, we have QKD-SAT and Quartz, the first precursor prepare and measure systems that we have been developing on QKD. But obviously, the international competition is fierce, and it is a very interesting challenge for industry to meet government needs. Specifically, if we look at China, who's already moving to operating systems. Here on the right-hand side, you can see the backbone chain of trusted nodes that connect Beijing with Shanghai over Yunnan and Hefei. This is 2,000 kilometers roughly optical backbone, but it is being extended by their free space QKD satellites. We are not quite clear internationally what their capabilities really are, but we are aware that the second generation satellites are on their way, and Tiangong 2 will probably also play a big role in it. So there is a considerable international interest in QKD, and the European Union is not far behind with that. The European Quantum Communication Infrastructure Initiative was launched a few years back with a handful of countries, and now it is 26 EU member states who are very interested in generating systems, technologies, and closing gaps that can establish a quantum communication infrastructure all over Europe. I'm bringing EuroQCI up simply because everybody needs to understand here that ESA's Secure and Cryptographic Mission, or SAGA, is our response to this European initiative. We will be extending local nodes and connecting testbeds using our satellites that we're developing in SAGA. So while EuroQCI is already targeting a fully operational quantum communication infrastructure that is based on user requirements of EU users, SAGA is currently being developed to be the space component of that initiative. This means ESA is developing, designing, and validating that space segment under SAGA. And the whole idea of SAGA is to provide cryptographic keys for protected communication in Europe. Now, while this is very interesting, obviously this is European Union, and for Canada, what we would like to highlight very, very clearly here is that ESA owns all the activities under the SAGA project. That means the door is not closed. On the contrary, there are a number of opportunities for quantum technologies that are under ScyLight or SAGA. And this is why we have our activity stream for industry-initiated activities open. All of these activities are owned by third parties, which means are initiated by third parties, and they're all looking at the first commercially viable QKD services. That could be already a pre-operational or pre-commercial service, but it could already just be a tech demonstration. We call these activities contributing missions to SAGA, or abbreviated SAGA-CON. And these are completely segregated from SAGA itself. They are self-standing projects within our activities at ESA, and they're obviously open to your industry as well. Of course, the selling stone for us was that this can be used as a program to develop a national industrial expertise in the view of EuroQCI, but this applies as much to European member states as it applies to you, simply because this could, a SAGA-CON mission is an industrially initiated activity where you can boost your capabilities without having to collaborate in any level with the EuroQCI. I would like to bring some examples of these activities. So Eagle 1, for example, is a low Earth orbit demonstrator that is in essence the ESA Quartz mission, but under continuation. We are continuing it under SAGA. We are collaborating also here with the Commission to bring an early test bed into low Earth orbit, where you can test your, in essence, concepts of operations using QKD from space. It would employ a prepare and measure protocol. So the satellite itself would act as a trusted node in space. But it would come with a full QKD key management system. It would have clearly defined ground terminals that you can already test on your satellites. And it would allow to test the overall space operations of a key distribution system where a trusted node is in space. For that, Eagle 1 is actually quite a good example for a SAGA-CON mission, because with a single satellite, you can have global coverage. So it doesn't really matter where your ground station is. As long as at a couple of minutes at night, you're in view of the satellite, you can go and test away. And obviously, the idea is that such a testbed could help to integrate systems that are not able to be connected yet on the ground. So if I look at the Canadian territory, quite obviously, you have a lot of ground to cover literally between your coastlines. So this is a very good example, but of course, let's say sky's the limit, quite figuratively here. We could imagine CubeSat or small sats in low Earth orbit carrying out several activities. We can imagine geosatellites to be a SAGA contributing mission with a number of key technologies you'd like to test. At the end of the day, under ScyLight or the other program that we have for security and for safety, the 4S strategic program line, the technologies you see here on the screen are exactly what we're targeting. It is very nice that we already have 1 or 2 or 3 suppliers for example, quantum random number generators. But one of these activities of ESA is to build a healthy industrial landscape and to foster new companies to improve on existing technologies. But it could also extend to your own key management systems, your ground stations, detectors, and so on. So there is really a lot to do, and we are very excited about this development. And I think with this, I already hand back now to Michel and Sylvain, and I'm happy to hear and take your questions in the Q&A session after Sylvain talked to us.
Great. Thank you very much. Thank you very much, Chris. And thank you very much, Monica, for talking about the focal points of the ESA technologies in this area. Now we're going to hear from Sylvain Raymond, and he'll talk about the Optical SatCom Consortium, where there are a collection of Canadian companies that are working on similar and complementary technologies. So Sylvain, I will pass it over to you to share your screen.
Yes, can you see my screen now, Michelle?
We can see a toolbar, but not your screen. So
okay, just a minute. I'll try again.
Yeah, that's a toolbar again.
Okay, I'm not sure on my screen it shows properly.
Oh, okay. Well, if you'd like, I can present your, I have your presentation here.
Sure.
If you'd like.
Sure, go ahead.
Okay. Just want to give me a moment. Great. There we go. And can everybody see my screen?
Yes, I can see that.
Okay, very good. So you can just prompt me to move the screen when you'd like.
Okay, can you go in full presentation mode maybe?
Oh, apologies. That I thought it was in full presentation mode.
Okay, maybe it is. So good morning, everybody, and good afternoon to those in Europe. So I think it's appropriate at this point after the presentation from Christopher and Monica to talk about Canada's Optical Satellite Communications Consortium. So we call it OSC for short. You'll hear that acronym. So my name is Sylvain Raymond, as mentioned, as presented earlier. I work for the NRC, and I'm going to talk to you about the Optical SatCom Consortium today. I'm filling in for Lynn Gennick, who's the chair of the Optical Satellite Consortium, as she's on vacation. So feel free to contact me, and we can always point you to the right persons. Next.
Sorry about that. There you go.
Yeah. So a bit of context for people. In 2018, the government gave a mandate to NRC to develop a challenge research program on high throughput and secure networks. And the goal there is to create technologies for next generation broadband internet, create technologies to close the digital divide, and transfer these technologies to organizations that can deploy them. So we ran a bunch of consultations in 2018, 2019 to build a program plan, and optical satellite communications emerged as a promising field, essentially disruptive in its impact in society. So we decided, the program at NRC decided to invest and to participate in that area of research. During the 2019 calendar year, the OSC was nucleated as part of the above consultations. There's several organizations that discussed the possibility to form a consortium to create an R&D ecosystem in Canada and eventually just simply create a commercial ecosystem. And then in September 2019, the Optical Consortium agreement was signed and OSC was born. Next. So we have a number of members that are represented here on this slide. SatCom, of course, is the secretariat. The level 1 members are the ones that are more heavily involved, and then level 2 and level 3 members. All of our members are very important. They bring something important to the table, but just wanted to give you an idea of the range of people that got together and participate in the consortium. Next. So just to explain to you at a high level the structure of the consortium, we're a member-based group. We bring together the technology innovators, the technology suppliers, the product manufacturers, and the end users in the consortium. And the objective here, derived from the mandate given by the government to NRC, is to perform R&D to support the development of next and next after next generation optical satellite communications this time, and to support the development of a Canadian ecosystem in optical satellite communications. So we have an umbrella agreement that provides a framework for collaborative R&D projects and activities. So we have a governance structure to organize the relationships between the members and the communications. We have confidentiality and then sharing clauses embedded in the agreements. Most of the IP sharing clauses are within the project agreements when people get together to form a research project. And we provide a good framework for multi-party R&D projects, which we have applied successfully in the past year and months to bring together many members working together in research and collaborative R&D projects. Next. So there's different membership levels when you join the consortium. You have to choose one. You must be a member of the consortium to participate in projects. I'm not going to describe to you in details all the conditions of each level of membership. Suffice to say, in short, that the higher the level of membership that you opt for, the higher the obligations you have, but also the higher the benefits you can derive. Next. So at a high level, our vision is actually very similar to the one from ESA. So this cartoon just depicts here what we are striving to achieve or striving to develop. So we're trying to develop technologies to enable fiber in the sky type systems. So you can imagine, for example, a constellation of LEO satellites interlinked via inter-satellite laser links. This LEO constellation is connected to the ground via an optical up and down link to a network of ground stations to try and defeat, of course, the cloud coverage. You need a certain diversity of ground station sites. You can also imagine links to geosatellites from this LEO constellation, and links to high altitude platforms like planes, UAVs, and so on as part of the network. So in the end, the idea for us, at least from the high throughput and secure networks program, from the mandate that we're given, is that if we can get the cost of having or building a ground station network fairly low, or affordable, you can imagine that you can now connect any 2 points on the surface of the planet, whether it's urban or in rural and remote regions, with fiber-like speeds via these free space optical links. As Christopher highlighted, if you have optical links, you can go 1,000 times faster than RF links. So this really is a challenge and a goal that we think is worth trying to address, and that gives us the motivation for the work that we're doing in the consortium. Next. So how do we organize our work? We start on the one hand from a system perspective. So we have an ongoing technology roadmap exercise at the moment that we plan to continue regular or update regularly throughout the life of the consortium, which is still going to be ongoing for several years. As part of that road mapping exercise, we study use cases, and from the use cases we derive certain system specifications that we think would be appropriate. And we downflow from that to the subsystem and module and component parts of the system, what the specifications should be. And via doing some R&D and prototyping, either with real devices or maybe via simulations, what are realistic specifications for modules, components, and the such, and feedback to the system level. What's a realistic specification that can be achieved, and go back to examine if it makes sense against those cases that we've defined, and feed that back in the road mapping and loop again. So that's the general idea. And now I want to mention that we don't have the mandate to build and demonstrate an end-to-end system like ESA does, but we do want to adopt that systems perspective really to help the members understand where the organization can fit in and can contribute in those systems, and be ready to participate in large projects when they come along, such as Telesat Lightspeed, ESA HydRON project, and other international big projects that are nucleating and happening now and in the future. Next. So from the other end, from a project perspective, how do things work? So if you take the specifications, for example, that you want to achieve in a module or a component, you can start with a certain design, and let's pretend for a minute that this is something where we need some improvements over what's available off the shelf. You can start with a design, a new design, of course, fabricate, package that, you test it, analyze the results, and you have to go through that R&D cycle until you get some satisfying performance, and your output is going to be a prototype or a product for your organization. What we can help with in the OSC is that we have an extensive pool of expertise and facilities that you can access via the partnerships in the consortium. For example, we have space telecom system architecture expertise, we have artificial intelligence expertise, both for network management on the one hand, but also for designs of photonics components or systems, for example. We have 3-5 fabs, including growth. We have extensive testing capabilities, and there's a lot more that many of the partners can bring to the table as well. So if you want to build a project, the resources available from the consortium, well, you have the pool of in-kind from the OSC members that you can draw upon, where people are looking to contribute into projects together. We have some funding from the NRC HTSN program, and we also have a special MyTax NRC agreement that allows you to leverage any cash investment you would make in a project at a very advantageous level. And of course, also from the fact that you have a good access to partners and people that really want to be involved and collaborate, it may lower the threshold for you to get a successful STDP and CERC or other funding applications successful. And then members have done that successfully recently, actually. The other thing that we can bring to the table is some major member facilities like optical and quantum ground stations, for example, which by being a member of the consortium facilitates the access to those. So all in all, we're a good venue to develop new components and systems from the ground up if you need be. Of course, if you want to pick the work from a bit of a higher TRL and adapt an existing technology, that's possible as well. Next. So just a few examples of current projects and activities here on the left-hand side. So we have the road mapping ongoing, as I said. We're initiating a system architecture project at the moment. Some of the work has started already, actually, and we're working also on several technologies and different components of the system. I want to highlight that the road mapping is an open activity for all to, in which all OSC members are invited to participate. I think it benefits everybody to participate in that activity. I want to highlight also that our initial set of projects were selected via more of a bottoms-up approach. It's the members themselves that said, you know, we think that this is useful. Now, over time, as we progress in the road mapping system architecture, we're going to mix that with a top-down approach and have a good conversation on how to continue on these projects. I want to note that new projects can be initiated at any time, but at the same time that the funding availability varies over time. So I don't want to pretend or give people the impression that there's vast amount of money available. This is funding from NRC, which is limited. It's seed funding, but it's there. It does help, and it does support the projects on the left, and people are very grateful for that in the consortium. So if you want to have a bit more details about the projects, you can see the website from the consortium. Next. So that's what I want to talk about. Very quick summary. So we're a member-based organization with a mission to develop optical satellite communication technologies. We're trying to leverage Canada's strengths in both space technologies and photonics, and blend the two together. My own background, for example, is in photonics. I have a little background in space technologies, so it's a learning curve for me, but I think it is for a lot of members as well. We provide a framework for collaborative R&D. We're a good place to develop technologies and expertise in optical SatCom, so you can get ready for upcoming projects like HydRON and next phases and things like that. I do want to mention that we have a growing relationship with international partners. Christopher, for example, has heard about me probably a lot too much over the last 2 months. So I think that's very useful. We're bringing these relationships from the Canadian perspective as well, and helping to tighten those links and make them stronger. And if you want to communicate with us, you have the contact here. And thank you very much for listening.
Great, thank you very much, Sylvain. So what we're going to do is we're going to go into questions and answers now. So what I'll do is I'll ask everyone who may have a question to raise their hand, and then we can go into, I'll call on certain people to ask their question. You can unmute your mic and you can activate your camera so that we can hear from you. So first I'll go to Ashley O2.
1, 2, 3. Can everyone hear me?
Yes.
Perfect. Firstly, a big thank you to Ms. Michelle Mendez, and a big thank you to Solomon Raymond and everyone in the panel. You've all been incredible. My first question would be that while the idea of HydRON and everything is very promising and great, have you come up with a solution to avoid satellite collisions? Because that has been a big concern recently with the debris currently in orbit, as well as what recently happened to the Canadarm2, where no one noticed that there was a breach until a few days later based on a delay or something like that. So is there an actual solution to solving that first before this constellation of satellites is released? Because we now have a new issue where so many countries are saying we want to release a constellation of satellites, and that's kind of frightening when the debris issue is not being solved. So has ESA as well as the Canadian Space Agency come up with solutions to solve this problem? I give way. Thank you so much.
Thank you, Ashley. Go ahead. Sorry, go ahead, Chris.
Thank you, Michelle. Yes, indeed, this is of great concern to ESA, but When we are looking at the space debris issue itself, it is very difficult to break space debris mitigation or the surveillance of the airspace down to single missions. So if we were be doing that, then we would not be developing new satellites at all. That being said, ESA has an initiative, Clean Space, as well as a strong footing in the international community when it comes to space tracking, safety and surveillance, also together with our Canadian partners. This has to be a collaborative effort. So at the end of the day, this would be oversimplifying it to break it down to a single satellite system that could solve all your issues. And you have a very good and a very substantial point there indeed. If we are not able to protect our space assets in space, then we are risking of damaging the hardware that we're putting up there and even making our orbits unusable for quite some time. So this is a big ongoing activity that requires technical innovation, that requires regulatory and law collaboration, but that requires also an immense amount of international collaboration. So I'm unfortunately unable to give you a very clear technical solution to this problem. They are bottom of it. But the topic itself is quite complex, because imagine if a European satellite would go to an American satellite to fix it unannounced or to take pictures of it close up. There is a huge context that first needs to be elaborated, and I'm guessing many of you here in the audience are very knowledgeable on that topic as well. But to answer your question completely for HydRON, our satellites are currently still being in development, and we are obviously very aware of this issue. And as soon as we have a bit more clarity of how our systems would look like concretely, we would have to consider space debris very, very closely in terms of deployment, in terms of what kind of risk they pose to our system. So it is clearly on top of our mind, but HydRON itself is a communication demonstration system and not necessarily a space debris mitigation. I'm not sure, Monica, if you want to add something, because you're the sys engineer here. So
yeah, I can add something. Actually, let's say from the international cooperation and legal point of view, you covered already, Chris, because if I don't know what's going to happen if an American satellite hits a Chinese one or whatever. But from a technical and let's say self-regulatory point of view, ESA has implemented, starting from this Clean Space initiative, already for the last, I would say, maybe 5 to almost 10 years, some technically growing requirements that initially they were grouped into an ISO, I think, standard, and now it is becoming, if I'm not wrong, because in the last couple of years I have not followed the administration, but I think now is becoming also an ECSS, so it's already an ECSS. So the idea is to have a technical standard, and we are basically what we are doing. We're working on 2 main aspects. One is the re-entry capability, if mandatory requested to each project, if let's say a natural re-entry capability if there is no propulsion on board. And so basically this is limiting the altitude that we can launch, so to roughly speaking 500 to 700 depending on the conditions kilometers. And then also to implement some let's say mitigations on board, like deactivation of batteries. I mean, things that probably are in common to every country nowadays and every agency. Some of these technical requirements are now becoming quite standard. For example, the deactivation of the batteries. Others are still so challenging, like the deactivation of the solar arrays, that can be extremely crucial. If you deactivate by mistake, you lost your mission. So some of them are still under elaboration from the technical directorate, but let's say that we are implementing more and more sort of self-discipline requirements. So that's what we're doing basically. And this is now mandatory. It used to be in a transition phase, partially optional, but now it's mandatory to every satellite that is developed within the agency. For HydRON, though, we don't know yet whether we will develop our own or buy our own platform, or just being on board, I mean, carried, hosted on board an opportunity satellites. But in that case, imagine the worst, let's say, legal case that we are hosted on board a satellite that is offered by an operator and we cannot do anything about those technical features. What I assume is that we will probably be selecting the opportunity based also on the debris mitigation policy. I hope that this answers your question.
Great, thank you very much. So our next question is from Peter DeSelding. Peter, if you'd like to unmute yourself and ask your question, please.
Hi, I've just unmuted. Is the audio okay?
Yeah, we can hear you.
Okay, thank you. For either Christopher or Monica, and this is, I know, the complicated question, but because we've got Canadians here, and there might be British people in the audience and so on, the question is this: what do you say to people involved in the ESA, HydRON, or other optical programs when they know that sooner or later the ESA effort is going to be somehow not given over, but at least merged into somehow the European Commission program, which is the main event, right? They won't necessarily be allowed to take part in that. I mean, is there this something that's not been decided yet? Just how do you negotiate that?
Excellent question. Hi, Peter, and thank you for that. The HydRON activity itself on the ScyLight is not the sideshow and is completely segregated from the European Commission, because HydRON and telecommunication activities are run by us, and we currently don't foresee any handover or closer collaboration on HydRON with the European Commission. This, however, is very true for the SAGA system. So the SAGA system as a space component that deals with the quantum communication and quantum key distribution as a first step will indeed be tied into the European Commission, and you beautifully outlined the complexity of this issue, specifically given that the formal collaboration with the European Commission is currently still being worked out in its details. When it comes to these quantum technologies and development of quantum technologies, what we can say to Canadian and to British entities who might be listening right now, or whom we are writing to, is that because we have taken a keen look at segregating our programs at this stage from the European Commission, we are able to create tailored activities such as the SagaCon missions that we just described before, that will not be subject to this interaction with the European Commission. ESA has a long history, obviously, of collaborating with the Commission, and very good success stories there. So yes, indeed, it's making our life easier, but we have done this before, this clear separation of houses, let's say, and we are doing it right now as well. And a good example of that would be the QKDSat activity that is still ongoing, that has nothing to do with SAGA itself, as well as dedicated quantum technology activities that we have taken out of the small project into ScyLight to be open for Canadian and UK partners. Thank you. I hope that answered your question.
It does. Thanks.
Great. Thank you, Christopher and Peter. I just want to let everyone know that one of the questions in the chat was asking how to find out about the invitations to tender, and Chris has kindly put the link in the chat. So if you would like to refer to your chat, you can find the link to the ITTs there. Also, there was a question from Raj Narula. Are projects restricted to optical hardware development, or are software-based solutions advancing photonics applications considered as well?
Yes, thank you.
I was going to answer directly just now. Actually, we have not pre-selected anything at the moment. It's true that hardware solution, I'm not an optical expert in neither photonics, but hardware solutions are those that probably come more natural, at least on our side. So I've been checked first, but probably in view of some type of flexibility, that is what we hope that the HydRON management layer will be able to offer. I would not exclude on our side for the moment software solutions, but maybe I leave it also to Sylvain to see on their side what they have envisaged.
Yeah, so from the OSC, thank you, Monica. From the OSC perspective, I wanted to mention that software solutions are in our plans. We're actually working on that. We have projects actually dedicated to that, and there's two main avenues in which we're doing that. One is for the networking aspect. So simply because we're considering now networks of mobile stations or satellites. It's very complex. The routing, for example, is very complex and very dynamic. And so one of the aspects is looking at networking, how to route the signal as a function of time, and AI and software plays a very important role in that. Also, you have to, in LEO satellites, for example, the satellite is in view for only about 11 minutes from a particular ground station. You have to manage the handover from one satellite to the next for a particular ground station. There also artificial intelligence software can play a very important role. So those are examples. In the networking aspect, we have one project dedicated to that. We actually have our experts in the audience today on that project. I can connect you with them if you want to talk to them. The other aspect is also to use the AI and the software to help the design of the photonics component itself. And NRC has been working very heavily on that in the past 3-4 years to develop artificial agents, machine learning tools to help optimize very efficiently the photonic components that are needed for any type of system. But here we're applying that in the consortium for optical systems or photonic components for optical satellite communications. And we are doing that in projects that involve actually academia, NRC, and industry together to really develop a next generation photonic circuits, and it really looks like those projects are in good trajectories and will be very fruitful in the coming months. So I hope that that's answering your question, and feel free to contact me if you have more.
Okay, thank you very much, Sylvain. So I think what we're going to do is we're going to go on to next steps. Again, if there were any questions that anybody had, I am going to take the questions in the chat, and I will make sure to send them to the participants so that you can see what answers were given in the chat. And then again, any questions that were asked and answered here are going to be posted in the recording. So perhaps I'll hand it over to Chris for the next steps, and then maybe Sylvain wants to chime in as well about any next steps within Canada.
All right, thank you. Let me quickly share my screen for the last slides. I hope you can see them now. In terms of next steps from our side, we are currently, as Monica already introduced, in the throes of trying to nail down our HydRON demonstrator system, our first step to develop a HydRON end-to-end system. And this will be happening in the next coming months. So this is where our focus is at the moment. That being said, we are looking forward to an industry day later this year, hopefully, with our partners at the CSA in Canada. We are not quite sure yet whether we will be able to join you in person or online, given the situation. But we see this kind of engagement as a very important step for us to make sure that HydRON and ScyLight activities are in line with your needs. So quite clearly, what the next steps for you would be is check out our doing business with ESA page. Simply because I've seen the questions in the chat. Some of them also reached me privately in a private chat. On the ESA staff publication, you find our current ITTs that are out there. You find some descriptions about it. You find some information about the procurement process ourselves. But most likely, it should also bring you very closely to Sylvain, the OSC, as well as our colleagues at the CSA, to be sure that you're walking the right direction and that you find your government and national stakeholders at the very early stage that you can actually successfully run and be part of these activities. For us, you already saw the "I like to move it" animation. This is Harald Hausschild's favorite motto at the moment. As a key message, you understand hopefully now that ScyLight is the program at ESA where we try to bundle all of our optical and quantum communication activities, that it is part of the Telecom and Integrated Applications Department of ESA, that our high throughput optical network satellite system implementation is becoming a reality. It is no longer just paper, but we are actually looking for concrete funding for the mission in the coming Council Ministerial. For those who are not familiar with it, this is ESA's financing cycle, where we go to our ESA member states and ask for funding for specific projects. So HydRON is one step closer to becoming a reality, and it cannot happen in disconnection from industry. That is very important for us to understand. The users have to be sitting at the table as much as the governments, as much as the agencies, in order to make HydRON a success. And finally, I wanted just to highlight again that while SAGA is a dedicated activity that is supporting the European Commission to build Europe's quantum communication infrastructure, the ESA SAGA program is able to support you in your quantum and your cybersecurity activities that you would need to be developed with ESA. And just because we have the activity ongoing with the European Commission, it should not deter you from raising your hand, sit down with your agency and try to define a way forward, how we can collaborate with you. So we are very open to that. And I think I will just leave it at that, and I will hand it over directly to Sylvain to wrap this up. What are the next steps ahead?
Well, from the OSC perspective, the next steps. So for us, we really have to continue and complete the first issue of our road mapping to understand where the Canadian ecosystem can sit and contribute. But we don't. I mean, this is still going to take several months. I think in the meantime, another next step also is to really identify the opportunities to work with ESA or other partners, maybe at the international level, but Canada can bring and contribute to some of the technology parts or some of the systems in the HydRON. I have identified a few already where I think we might be able to. So just listen to the community, basically, is really what it is. See how I can help and improve or lubricate, if you want, the relationship with ESA and the international partners. So it's I think it's very important for us to cultivate those relationships. And I want to mention that the OSC is also looking at probably getting involved a bit more in the quantum security aspects. And perhaps also we have an eye on metrology internally. Some of the OSC members have mentioned that metrology may be an important aspect with optical SatCom, or that there's some niche applications there. And yes, I think that's about it for me. I really the OSC is a members-based group, so we have to listen to what the members think that they can do, and we're there to help. And that's it.
Yeah, so thank you very much, Chris and Sylvain and Monica. Really appreciate all of the information today. If anybody has any questions about the consortium, they can also contact me. I've put up some contact information here for everybody. That can be your starting point, and we can get you connected to the individuals or the departments at ESA, at the Canadian Space Agency, or individually at the National Research Council. So again, Satellite Canada Innovation Network manages the secretariat for the Optical SatCom Consortium. So if you have any questions about the agreement or how the consortium works, I'm very happy to answer those questions, and Sylvain can answer any of the technical questions on this side. So we would like to thank everybody for attending today. We had a really good turnout, and the information provided today, I think of as a starting point for Canada to begin its relationship with ESA and its HydRON program and the ScyLight program as well. So thank you everybody for attending. Again, this was recorded, and we will be posting this on the Optical SatCom Consortium website, and we'll be posting this on the ScyLight Canada Innovation Network website. And those are posted on screen right now. So thank you, everybody. I'll be sending an email to everybody to thank you for your attendance. And again, we'll be including some of the questions that were answered within the chat. Chris, Sylvain, Monica, thank you very much for taking this time during holiday time. And thank you everyone for attending.
Yeah, I want to give a special thanks to Christopher and Monica. They have been shown a highly collaborative spirits with us, and it's really appreciated.
Thanks a lot. It has been a pleasure on our side.
Thank you.
Exactly. Thank you very much, everybody. Thank you for having us today. And I can just echo what you said, Sylvain. This effort has to echo what is needed on the ground. So it's great to see that that little pond that separates Europe from Canada is easily bridged with these technologies we all got so used to in the past year.
Exactly. Well, thank you very much. I'm going to end the broadcast now. If anybody has any questions, please feel free to reach out. Thank you. Bye-bye.
Thank you
very much.